Okay, let's explore composite functions, and we are going to start with just two functions and have them composed together. So what does it really mean when we talk about a composite function? Now, not all composite functions exist. There is a test for it. So for example, if we call a function gf, it only exists if and only if the range of f is a subset of dg. What does that really mean? So if you look at the diagram below, a composite function starts with the first function, and I start with f. And what happens is f function is going to go in, has to fit into the function of g. So then if we talk about the function gf, we start with the first function, and we call it function f, and it would have to fit into the function g. So in a function f, for example, we do know that this is its domain, and the output is called the range of f. The range of f is a set of values, and to check and to ensure that this set of values can fit into G, it would mean that this intersection here is going to behave like a nut and a bolt. All values of Rf has to fit into dg, and that is the reason for this condition to check if a composite function exists. So let's practice before we move on. So if we are talking about the function fg, do remember that the first function starts with g and it has to enter into function f. So we are talking about what comes out of g, function g. What comes out is the output of g, and this set of values have to fit into df. And so let's look at our answer here. This would then be the test for function fg. Only if we do this check does it mean that the function fg exists. So we'll do specific examples later. Now please go ahead and try for the next three, and each time you may pause to check your answers or write them all out before we review all the three answers. Okay, we have done an explanation for the test for composite function, and let's say if a test had been done on the specific values and we concluded that gf exists, the composite function exists, then the following conditions will be fulfilled. So we can now assume that if gf exists, the domain of the composite function would be equals to the first domain of the function f. So which also mean that all the set of values that enter in is obviously also the domain of the composite function. Now the range of the composite function, however, will be restricted by what happens in the process of composing. So this one we will see specific examples later on.